Hey guys, welcome back to Algebra 2. So this is second semester, chapter 10, section 4 out of the Big Ideas math textbook. And we are going to find probabilities of disjoint and overlapping events. And we need to remember what our deck of cards looks like for today's lesson. So let me skip that real quick. Here is our deck of cards. Now let's talk about overlapping events and disjoint events. Basically what happens is maybe I want to pull a heart. So I might ask you what's the probability of, whoops, why did I say that? What's the probability of grabbing a heart out of the deck? But then I could say something like, well, it could be a heart, or it could be a 2. Now the thing about grabbing a heart or a 2 is that there is a 2 of hearts. And so your probability is going to change because there is a 2 of hearts. And so that is an overlapping um, event. Okay, so let's go back here. Here's our overlapping events. And what's important is that you find the probability of the first event happening. You find the probability of the second event happening, and you subtract the probability of both of the events happening at the same time. So let's go back here to our hearts. The probability of getting a heart here is 13 out of 52. The probability of getting a 2 is 4 out of 52. But the probability of both of those things happening, drawing a 2 of hearts, is a 1 out of 52. And the way the formula goes is it says, well, if you want these probabilities, you add the individual probabilities and you subtract the probability of them both happening. And so then our probability would be whatever that is. In this case, it's 16 over 52. And quickly in my calculator, I got 0.31 or 31%. Okay, that is how this works. Now, what if I said something like, I want the probability of getting a face card or 5. Well, the probability of getting a face card, count how many face cards you have here. It's 12 out of 52. And the probability of getting a 5 is 4 out of 52. Is there a face card that's a 5? No, there's not. So they are disjoint events because they are not overlapping. They never happen at the same time. And all we do simply add the events. So we'd come over here and we would get 16 out of 52. Hey, that's a nice coincidence. And that would be 31 or 31%. Okay, so that is what disjoint is and overlapping. So now you are ready for our examples. It says a card is randomly selected from a standard 52 card deck. What is the probability that the card is a 10 or a face card? Okay, 10 or face card. So I'm going to go back here. I want a 10 or a face card. Well, what's the probability of grabbing a 10? 4 out of 52. What's the probability of grabbing a face card? 12 out of 52. Are there any face cards that are 10s? No, there's not. So you add and you get 16 out of 52. So let's come back here. The probability is 16 out of 52 or 0.31 or 31%. Okay, let's try some more. A card is randomly selected from a deck of 52 playing cards. What is the probability it is a face card or a spade? Okay, I need to look here and get my face cards, which we just had, or a spade. Face or spade. Okay, now look at your face cards. You have 12 face cards. Look at your spades. You have 13 spades. Now, look at your face cards that are spades. Spade, 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 face, face, face. That is 3 out of 52 that are both. Excuse me. Okay, so we are going to add and we are going to subtract. Add, subtract. And that leaves us with something over 52. Okay, use your brain. 22 over 52, which is 0.42. Okay, so that's this question here. The probability of getting a face or a spade was 0.42 or 42%. Not bad chances. Okay, out of 200 students in a senior class, 113 students are either varsity athletes or on the honor roll. There are 74 seniors who are varsity athletes. There are 51 seniors who are on the honor roll. What is the probability that a randomly selected senior is both a varsity athlete and on the honor roll? So, what's happened here is they've given us the or, they want the and. So if you don't remember or you don't have your cheat sheet in front of you, you need the formula. You're looking for the or. It's equal to the probability of the individual events minus the probability of both events, the and. Okay, so come back to the problem we're working on. It says the or, which is 113, and it's a probability, so I'm putting it over 200, is equal to the probability of the individual events added together minus the probability of the and. Okay, so I have 74 students who are seniors, varsity athletes. I have 51 who are seniors and on the honor roll. The and is my variable. It's like the x. Okay, so we need to add here. So 74 plus 51. I have 113 over 200 equals 125 over 200 minus, whoops, that's supposed to say minus, x. Okay, now I want the x alone, so I'm going to go ahead and subtract 125 over 200. So I get negative 12 over 200 equals negative x. Now I'm going to divide by negative 1 or multiply by negative 1, whatever. X is equal to 12 over 200. So 12 divided by 200 in my calculator is 0.06 or 6%. That is how we do this. Okay, a card is drawn from a standard deck of 52 playing cards. What is the probability of drawing a 4 or a red? Okay, a 4 or a red. I'm going to go back to my deck. Oops, too far. I'm looking for a 4 or a red. 4 or red. Okay, well, how many red cards are there? There's 26 red cards. Oops, I wrote that in the wrong spot. There are 26 red cards. How many 4s are there? There are 4 4s. How many cards are red cards and 4s at the same time? Okay, that's your hearts and your diamonds. You've got 2 of them. You add the individual probabilities. You subtract the overlapping probabilities. And so you get 28 out of 52. And so you have 0.54 or 54%. Okay guys, that's it. 11 minutes. It's that easy. We are done with our lesson. That was our check. 54. So hopefully you understand and you're ready for your practice work. Hope you're having a good day.